Hello students, today we will study about the photodiode characteristic. So we are going to find out the photodiode characteristics and also we are going to calculate the power responsivity. So your apparatus required is this photodiode characteristic kit, and this is the photodiode. Here this is a LED and this is the photodiode. Light will be emitted by the LED and it will fall on the photodiode, which converts light energy into the electrical energy. This is the circuit diagram to find out the photodiode characteristics and also the power responsivity. So these are the two graphs we are going to plot. From first graph, that is IPD, current across the photodiode, versus power across the photodiode, that is PLED. Whatever the graph you will get, that is a straight line graph. The slope, by using the slope we are going to find out the responsivity. Then the second graph is VPD, that is the photodiode voltage across the photodiode, versus IPD, that is current across the photodiode, which will give you the photodiode characteristics. So this is the formula to find out the responsivity. From the first graph, that is slope by 0.66, the value whatever you will get, the unit is ampere per watt. So these are the two tabular columns which are needed to find out the power responsivity and photodiode characteristics. Here we are going to keep VPD 1 volt, and by changing PLED, that is power across the LED, and corresponding change in the current should be noted down, that is IPD. In the second part, VPD kept constant, PLED, that is power across the LED, should be kept constant, that is 10 milliwatt, and we are going to change VPD, that is voltage across the photodiode, and corresponding change in the IPD should be noted. This we can do for the another values of the PLED, that is 20 milliwatt, keeping 20 milliwatt constant for PLED. Again we are going to change VPD, and corresponding change in the IPD should be noted. It can be repeated by 3 to 4 times. So here first we will see the connections. So these two points should be connected first. Then this is the voltmeter, which records the voltage across the photodiode. This is milliammeter, which records the current across the photodiode. So here first we are going to connect this positive of the voltmeter to this positive, then negative to this negative, then this positive to this positive, then negative to negative. Then here this is the photodiode connection. This positive should be connected to this negative, then photodiode will be connected in the circuit, and this negative to this positive. This is the photodiode symbol. So first part is, first we on the circuit, we are keeping VPD constant. By using this knob, we have to keep 1 volt constant as VPD, that is the voltage across the photodiode, and we are going to change the power across the LED from this box. For 10 volt, then what is the current? The next 11 milliwatt, corresponding change in the current, then 12 milliwatt, corresponding change in the current, and also every time we have to keep VPD constant as 1 volt. Every time it should be 1 volt, and corresponding change in the current you have to note down. This you have to repeat for all the values of this PLED up to 50 milliwatt. Then keep this is in the minimum position. So whatever the readings now we have got, those are for the first part. Then for the second part, we have to keep PLED constant, that is 10 milliwatt, and we are going to change the voltage, that is VPD, and corresponding change in the current we have to note down. In the steps of 0.1, 0.2, we have to change the voltage, corresponding change in the current we have to note down. This is for the one value of the PLED, that is 10 milliwatt. After completion of the readings up to 1 volt, again you have to make this minimum. Then you can go for the next value of the PLED, that is 30 milliwatt. Change VPD in the steps of 0.1, 0.2, and corresponding change in the current you have to note down. After some time the current will remain constant. There you can stop. Okay, so that will be the second set. Again keep it minimum, go for the 50 milliwatt. Again change VPD and corresponding change in the current should be noted. So here you will get for the 3 sets of PLED, the sets of VPD and the corresponding change in the current. Then after getting the values, you have to plot the graph of IPD versus PLED. That graph will give you the straight line and its slope will give you the responsivity, that is responsivity R is equal to slope upon 0.66. And the second table, whatever we have got the readings, we have to plot VPD versus IPD. That will give you the characteristics. Each line will be for one PLED, whatever we have kept constant, 10 milliwatt, 20 milliwatt, 30 milliwatt. That will be the characteristic of the photodiode. So this is for the photodiode characteristic graph and this is for the responsivity. So here result will be the responsivity of the given photodiode and also the IV characteristics of the given photodiode is verified.